Thanks.
Thanks, Jim. And whereas Stephen concentrated in the last talk on the way in which the public might interpret information and use information you give them about climate change, I'm going to focus now on policymakers, particularly national governments, and the way in which they are provided with information, the kind of information they're given, and the way in which they might use it, and ways in which we might need to improve it. Okay, so I'm going to start with the United Nations Framework Convention on Climate Change from 1992. Nearly about 200 governments have now ratified this, including the United States. This is essentially the overarching principle, Article 2 of that convention, that guides international efforts on climate change, and that's the avoidance of dangerous anthropogenic interference with the climate system. In the convention, it doesn't define what dangerous is, but since 2010, through the annual meetings of the parties to that conference, there's now been an agreement that the dangerous level of global warming is either 1.5 or 2 degrees above pre-industrial level. But obviously, for policymakers, in order to make well-informed decisions about avoiding dangerous interference with the climate system, they need information. And that's where the Intergovernmental Panel on Climate Change comes in, established in 1988 by the World Meteorological Organization and the United Nations Environment Programme. Its job is to provide assessment on all aspects of climate change. As everybody here I'm sure knows, they produce regular assessment reports on climate change, the most recent of which, the 5th assessment report, was published this year. Now, those consist of 3 very large volumes and a 4th synthesis report. Each of the volumes has a summary for policymakers that is particularly focused on policymakers. And so for the purposes of talking about the information provided to policymakers, I'm going to concentrate on the summaries, because that should be where the information is distilled down for the most important pieces of information that policymakers need to make well-informed decisions. It's important to recognize that the IPCC proudly clings to this notion of being policy relevant but policy neutral, and for that reason it doesn't provide guidance on which policies should be pursued by governments. So I'm going to concentrate on the synthesis report of the 5th assessment report, which was published last month. And one of the key findings from that is at the bottom there, which pointed out that this is really, climate change is really a risk management problem. The diagram above it appears in Working Group 2's report. It shows how a combination of hazard, vulnerability and exposure all combine to define the risks, and that it's the hazards that are being affected by the increase in greenhouse gas concentrations in the atmosphere. Implicit in this, or explicit in this statement at the bottom, is that we can do things to manage the risks, but adaptation has its limits. There is a limit to which you can adapt to the impacts of climate change, which means mitigation through reductions in greenhouse gas emissions is also necessary if you're going to avoid the most dangerous impacts of climate change. Now, to make a progress with risk assessment, the first thing to do is to understand how other areas of policy are communicated where there are risk assessments. This diagram, which I'm afraid is a little bit fuzzy, this is taken from the UK's National Risk Register for civil emergencies, and it gives a whole range of risks that are currently taken into account by the government when planning how to deal with civil emergencies. On the right-hand side, you'll see a scale of various events that they plan for on which they've assigned likelihoods. And I would draw your attention to the fact that the least probable events in that is a cutoff at 1 in 20,000 events. This is judged over a 5-year period. So I want you to retain that figure, 1 in 20,000 event. Anything that is more probable than that goes in this. Also on the left-hand side, they have a series of terrorist attacks and other information where you can't assign an exact probability, but they look at these events and assign a plausibility. So the fact that you do not have enough information to assign a precise likelihood is not a reason not to consider a particular outcome. Now, you don't need to read through all this, but this is about time scales for policy. I mentioned that for civil emergencies, they look 5 years ahead. That's not going to be appropriate for climate change, but this is from the UK body that looks at radioactive waste management. And it basically says that at the minimum, you look at the next 300 years. The reason for that is that institutions are likely to have responsibilities that can be legally enforced for up to 300 years. But in the case of radioactive waste, of course, it will continue to pose a potential threat to public safety long after that. And you may know that in the US, of course, the time horizon they use is 1 million years. So they look at the potential threat to public health posed by radioactive waste for 1 million years into the future. Now, if you look at all the ways in which various risks are assessed in these other areas, you end up with these 4 guiding principles. Choose an appropriate timescale which allows risks to be properly appraised. Consider the full range of probabilities and full range of possible consequences before applying cutoffs. Identify the biggest risks which need to be avoided. They can be the ones that are severe, pervasive, potentially irreversible. And don't just focus on the most probable consequences. And 4th, define plausible worst-case scenarios if there is deep uncertainty that doesn't allow you to assign precise likelihoods. So I'm going to take now information from the summary for policymakers and take some examples and test it against those criteria. So this is the graph of global average surface temperature projections. And let me draw your attention to 2 particular aspects of it. The first is that it cuts off at 2100. So essentially the horizon that is considering risks stops at 2100, doesn't go beyond that. The only information in the whole of the summary for policymakers about temperature change after 2100 is that statement at the bottom. Warming will continue beyond 2100 under all of these concentration scenarios, except the one in which you cut sharply. That's the only information provided to policymakers about that. That's important because this is in the main report, the synthesis report, and you can see at the bottom that temperature continues to rise significantly for certainly for the most extreme scenario, but also for some of the less extreme scenarios, well beyond 2100, and yet you're giving no information in the summary for policymakers about this information. There's no real justification for stopping at 2100. You've automatically cut off some of the most severe potential impacts of climate change by applying what is essentially an arbitrary cutoff. Similarly, the ranges presented in those projections are what is described as the likely ranges, and they are basically cover between 66 and 100% of the distribution of temperature changes that are associated with a particular emissions pathway. Now, in order to generate that, they use climate models, and the models make assumptions about various things, includes in it an inherent property, the equilibrium climate sensitivity, which is defined as the long-term adjustment in global average surface temperature in response to a doubling of carbon dioxide concentrations in the atmosphere. Now, you'll see on the left is from Working Group 1's report, a range of the estimates that are applied to the value of equilibrium climate sensitivity. There's a range of uncertainty there. And the statement in the top right-hand corner is the statement from Working Group 1 about the equilibrium climate sensitivity. Let me draw your attention to the very final part of that. Very unlikely that the ECS is greater than 6 degrees. Okay? Very unlikely in the IPCC's terminology is a 1 in 10 chance. And yet that's all that it puts in there. A 1 in 10 chance. Remind you that for the purposes of civil emergencies, 1 in 20,000 is the cutoff of considering extreme events. And there's something that's potentially catastrophic. I mean, a 6-degree rise from a doubling of CO2, which we probably will see in the second half of this century, it would be hard to contemplate. 6 degrees warmer than today, we haven't seen on Earth for tens of millions of years. We don't have historical experience. We don't have experience as a species of that. I've just given an example of temperature, but it also applies to sea level rise. This is also from the Summary for Policymakers of the Synthesis Report. Again, a 2100 cutoff. Also narrow bands of likelihood, all sorts of uncertainty related to the stabilization of the polar ice sheets is not represented in those projections. And this again is from the main body of the synthesis report that shows once you go beyond 2100, you start seeing from the model information very big rises in sea level. Now, you should remember that about 200 million people worldwide currently live within 2 meters of sea level along the world's coastlines. And so that information is absolutely crucial if you're assessing to what extent the climate change is going to have an impact on people. So I've just gone through some examples. They are taken from a study which we're going to be publishing early in the new year. It's been done in conjunction with the Foreign and Commonwealth Office that is concerned that policymakers are not aware of the full range of the potential risks that we are facing through rising greenhouse gas concentrations. So these are the key conclusions we've drawn at this stage. The fifth assessment report is not a risk assessment of global climate change. It understands that these impacts should be defined in terms of risk, but it is not a formal risk assessment. It doesn't claim to be a formal risk assessment. The synthesis report summary for policymakers, the thing that is mainly aimed at decision makers, applies all sorts of arbitrary cutoffs that prevent it from presenting the biggest risks. If policymakers are going to make well-informed decisions, particularly about the need to avoid future impacts of climate change through reductions in greenhouse gas emissions, they need the information about the scale of those risks. Applying cutoffs that hide the scale of those risks makes no sense. It undermines the ability of policymakers to make well-informed decisions. And this is going to be crucial in the next 12 months as we lead up to Paris. We're going to try and get a new international agreement to cut greenhouse gas emissions. And so they really do need access to a proper risk assessment. It may be that a report being published by the Secretariat of the UN Framework Convention on Climate Change, which is looking at the 1.5 degree or 2 degree threshold, provides that information, but it is desperately needed for policymakers. And in that risk assessment, 4 crucial aspects. It needs to have an appropriate timescale. Stopping at 2100 makes no sense. It is not an appropriate timescale for assessing the risks of global climate change. You need to consider a full range of probabilities. Describing a 1 in 10 chance of a potentially catastrophic increase in temperature as very unlikely is downright misleading. It distracts attention away from an extremely important consequence. You need to identify the biggest risks, concentrate on those, the ones that need to be avoided, the ones that exceed our ability to adapt, and finally, where you don't have enough information to provide likelihoods, assigned likelihoods, you need to define worst case scenarios and have a look at the plausibility of those. Thank you.
A quick question, anyone?
So Bob, could you play that off what Stefan was talking about? My particular question is, How good do you think policymakers will be about dealing with consequences in the couple hundred-year kind of time frame? I think that seems hard for some people.
Well, it's hard for policymakers when their electoral cycles are very near term. But remember, the thing that needs to be got across here to policymakers is they need the information. You can't blame policymakers for making bad decisions if you don't give them the information. You need to convey to them that the scale of the risks, what the scale of the risks are, and remind them that it's the decisions are made now. There is no going back. There is not going to be a magic wand that allows us to say, oh, well, if only we'd realize the risk, because we know that the carbon dioxide goes into the atmosphere, can last for hundreds of years. So my focus is on the scientists and experts advising governments on being better at communicating about those risks, because that's the first step in making sure that they make well-informed decisions.
Okay, that was great. Thanks.